Hi, welcome to the ACT 2018 science portion. This is the information regarding passage number 3. So here we go. I'm just going to kind of summarize. So this equation right here is just telling you to take a metal and add it to hydrochloric acid, and it's going to get a reaction and you're going to get a gas, and this gas right here on the end is the thing that we're measuring. And so here's the equipment that we're using. So when you look at this down here, here's your metal, here's your liquid, the reaction is occurring in this flask, and gas is going to travel through here and travel into this cylinder, and it's going to displace the water. So that is in a nutshell what's happening in this equation. There are some procedures down here that you can read. Really, you only need to know a little bit for one of the questions, so I'm going to skip those procedure for just a little bit, and we're going to look at these two charts. So this first chart, experiment number 1, so this is experiment number 1, this is experiment number 2. In experiment number 1, the temperature is the same every single time. So the temperature is 30 degrees Celsius. But down here we're using different masses, and we're always collecting volume of gas, and we're always looking at the same ingredients. The second figure is showing you that the temperatures are changing, but we're using the same amount of grams of the same substances, and then we're still collecting a volume of gas. So the two experiments, the only thing that's really changing is we're going to change the mass down here and keep the temperature the same, and this we're changing the temperature and then keeping the grams the same. So let's go start the first question. So number 14. All right, consider the volume of gas collected in the trial in experiment 2. So we're looking at experiment 2 for nickel at 30 degrees. The same approximate value of gas was collected in the trial in experiment 1 for the same element, nickel, for the mass. So here we're going to go back and look at those two charts. So the first thing that we have to look at is the 30 grams of nickel, which is one nickel. This is nickel. And then we can see that if we come over here, it's about not quite 130 milliliters of the gas. And then they want you to compare up here, so we'd find just a little bit below that, find nickel, and then we come down and find this value right here. So then we're going to look and see what the answer choices are, and we can see that the correct answer is going to be H. It's going to be about 0.3 grams of nickel, or the gas basically that is collected. All right, number 15. How many temperatures were tested in experiment 1? And then, so we're looking at temperatures. How many tested were experiment 1, and how many temperatures were tested in experiment 2? So when you look at this first experiment, clean this up a little bit for you. When you look at experiment number 1, we know that only one temperature was tested. So we know that's going to be one temperature. And now this one's tricky because you've got all these temperatures down here on the bottom. But really, how many temperatures were tested? Only 5. So when you come down here in experiment 1, one temperature was tested and 5 were tested in experiment 2. So the correct answer is B for that one. Number 16. Which of the following statements describes the difference between experiment 1 and 2? In experiment 1, only Fe was tested, but in experiment 2, Fe, nickel, and zinc were tested. Well, we know by looking at this chart that the same elements were tested each time. So we know that that cannot be the correct answer. So we can get rid of that one. And then we know that in letter G, let's look at that one. So Fe, Ni, so their iron, nickel, and zinc were tested. But in experiment 2, only Fe was tested. Well, we know that's not true because we know that they tested the same ones every time. Letter H. The same mass value of each metal was tested, but in experiment 2, multiple mass values of each were tested. Again, just if you're not sure, this one we're testing different masses, and this one we're testing the same mass. So then down here, we know that this one is not correct either. And then letter J, Multiple mass values of each metal were tested, but an experiment to the same mass, and so that is the correct answer. It is J. Number 17. Which of the following variables remain constant throughout both experiments? That's where you had to do this little quick reading right down here. And so this talks about the procedures that were kept the same, 1, 2, and 3. This is what was kept the same, but in this one, the atmospheric pressure, the atmospheric pressure was kept the same throughout all of those steps. So that is the correct answer for this one. It is A is the correct answer for that one. Number 18. If a temperature of 5 degrees Celsius had been tested in experiment 2, would the volume of gas collected for Zn, zinc, more likely have been greater than 107 milliliters or less than 107 milliliters? And so let's look at that chart. So we're doing the second experiment. Let's clean this all up again. So we're looking at 5 degrees Celsius, which would be right over here, and we're looking at zinc. And so you can take zinc, and you can see just right off the bat, which one is zinc, the triangle. So right off the bat, you can see that zinc is decreasing. You can see it in the chart. So as zinc is decreasing, and so we would know that right off the bat, we know that it's not going to be greater. So let's get rid of those two. And so we know it has to be less. And so let's read our two options to decide which one would be the correct one. So less than 107 milliliters, because for a given metal, the volume of collected gas decreases as temperature decreased. Or this one is asking you the same thing, but it's saying collected, because of the given metal, the volume of the collected gas decreases as temperature increased. We're not seeing that at all. We're seeing as the temperature decreases, the volume of the gas decreases. So we know that the correct answer has to be H. And the last two. Here we go. Number 19. Consider the balance equation in the passage. Based on this equation, if 10 moles of hydrochloric acid HCl are consumed, how many moles of H2 are produced? So let's go look at this equation right up here. And so basically we're looking at this and this, and I'm going to rewrite it over here. So we have, and I'm going to move it down. So we have 2 hydrochloric acids converting into H2 gas, and then they're asking us to change it to 10 moles of HCl. So if you just go 10 HCl's is going to equal, what's the value here? And so you can just simplify. This is going to be 1 to 5, 1 to 5, and so we know the correct answer is going to be A, 5. And then finally, last question. Clean all this up. All right, number 20. Suppose that the trial in experiment 1 was 0.25 grams of zinc is repeated, except that the inverted graduated cylinder is replaced by inverted test tubes, each completely filled with 60 milliliters of water. Based on figure 1, how many test tubes would we need? So we're looking at this chart over here. So we're no longer using this, but we're using a test tube, and it only holds 60 milliliters of water. And so we're going to be looking at 0.25 grams right here of which element? Oh, it is the zinc. So we're going to go up and find zinc. And zinc is the one with the little triangle. So zinc is right here, and we're going to run it over. So we would need, so it's going to fill up about, what, 90, 100 things of milliliters of gas. And so we would need, if we had this, so this experiment's going to run, it's going to put 60 of the 90 into that chart, or into the graduated cylinder, and so we would need at least 2 graduated cylinders for this experiment to work. And so we would use this one right here. G is the correct answer for this one. You would need at least 2. You really only need 1.5, but you would need 2 of them. All right, that's passage number 3. I hope that helps.